welcome to week 9 lecture, which is an introduction to hypothesis testing. Now, hypothesis testing is a systematic procedure for deciding whether the results of a research study supports a particular theory which applies to a population. When we say systematic procedure, it has got a step-by-step procedure that we have to do in order to get the p-value and then the conclusion for our hypothesis test. Now, what we do, from a population, we take a sample data. We draw conclusion from analysis of sample data to the population this sample comes from. It is a procedure for deciding whether the outcome of a study supports a particular theory or practical innovation. For example, if we want to test a claim regarding mean design time of promotional materials in a company, we can use hypothesis testing. Or if we want to test whether a specific treatment decreases blood pressure in patients, we can use hypothesis testing. With this coronavirus situation, if we want to test whether the proportion of people without the disease in a specific city is less than the proportion of the diseased people in another place, we can use hypothesis testing to formally test this hypothesis. The core logic of hypothesis testing is the researchers test the idea of no effect. We call it H naught, and it is the null hypothesis. So we say that we test that the experimental treatment make no difference. If this idea can be rejected, so the experimental treatment makes no difference, if that is rejected, then the researcher can accept the idea that the treatment makes a difference. All right, so we will conclude that the experimental treatment has an effect. Now, the core logic behind hypothesis testing is from the general population, we take a sample, and in that sample, for example, we expose the group to a specific medication, or if we are talking about sales in a company and we are using a new promotional material, then we look at the sample that we have introduced that promotional procedure for testing, and then from the sample we get if we are testing for the average score of something, we calculate the sample mean x bar and the sample standard deviation s, and then we use different statistical analysis depending on, are we testing for averages or are we testing for proportions, and then is the population variance known or not, are we doing comparison of two samples, are we doing one sample and we want to hypothesize about its mean. We use different tests, and then from that test procedure we come up with a probability, and that would be the probability of observing a sample statistic, which is here our x bar, that he or she, the researcher, has observed if the notion of no difference or the experimental procedure had no effect was true. All right, and then according to that probability we draw conclusion about the population mean, so mu. We either reject the notion that the experimental procedure had no effect or affirm the hypothesis that the procedure did not have an effect. The logic underlying the hypothesis testing is after defining the parameter of interest. So when we have got a research question, first we have to formalize it to a null and alternative hypothesis. So if, for example, I say that I believe that the IQ score of students in data science is higher than the general population of the university students, what I do, I'm talking about the average IQ score. So I'm talking about mean. So the parameter of interest would be the population mean. So we say mu, and then we define it. So if I'm talking about the IQ score, I say let mu be the average IQ score of the general population of university students. Or if I'm talking about the individual tax payment for a specific year for a certain state, then I say let mu be the average tax payment for that state. If I'm talking about the proportion, for example, proportion of employees in a company against certain vote, then I'm talking about P. And here it should not be P hat, it should be P, because I'm talking about the population parameter of P. And then P hat would be the sample proportion we take. And here, so we say let P be the proportion of employees in the company against certain vote, and then take a sample, and then the proportion of that employees in that company from that sample, we represent it as P hat. Now, the first step would be to state hypothesis about the population. For example, if I'm talking about the income of certain group in a population, and we believe that their wage is less than a specific number, general population, we can put the null hypothesis, and we say that let mu be the average wage for employees for that certain class, and then we say in the null hypothesis, because we talk about notion of no difference, we say is equal to 30k, which is like average wage for the general population. Then in the alternative hypothesis, if I'm talking about the average wage for this group is less than that, we put mu less than. Or if I believe that no, this group, the average wage is higher than the general population for that class, I put mu greater than 30k or whatever. These are just examples. And then we take so we always put our null and alternative hypothesis before we take a random sample from the population, which would be representative of the group we are interested in. And then we take a random sample, and then we get mean of that sample, x bar, and s, the sample standard deviation. And we have got a comparison distribution we talk about, which is the distribution of the population of individual scores when the null hypothesis is true. And then we just say, for example, x is normally distributed with the average score and the variance for the population. Or if I'm talking about proportion for the null hypothesis, then x would be binomial with n and p, that we already talk about the parameters for different distributions. And as you can see, hypothesis testing that we are using here is a parametric statistical test, because we assume that the population comes from a specific distribution, and that's why we say that it's a parametric test. Now, in the hypothesis test, we have got null hypothesis, research hypothesis. So null hypothesis, it's the opposite of the desired result, what we are hypothesizing as a researcher or as a data scientist. And we say that the manipulation had no effect, or there's no difference between our group of interest and the general population. And this hypothesis is the hypothesis that we believe unless there's a strong evidence against it. Then we have research hypothesis. which is also called alternative hypothesis, and it is opposite of the null hypothesis, and it is what the experimenter or the data scientist desired or expected all along. And that is, for example, the manipulation did have an effect. And the hypothesis that we believe once the evidence is strong enough for it. Okay, so now you can see that we have come from descriptive statistics and moved to inferential statistics. And inferential statistics is we have a sample from the population and draw conclusion about the whole population. Inferential statistics can be either hypothesis testing or estimation. And hypothesis testing, there are different ways of getting conclusion from our hypothesis testing. It can be either using p-values or rejection regions. And then estimation, we did it in last week, confidence interval. So we estimate where our population parameter lies in a range of numbers.